I'm Anil Kumar. We'll explore square-based prism. The question here is, Peter has 4 meters square of plywood. He wants to use this plywood to construct an open-top square-based prism box with maximum volume. Find its dimensions to the nearest centimeter. We'll also take up this problem in calculus to derive a formula. For the time being, what we are going to do here is to approximate the values, right? So we'll approximate to 10th place, right? Okay, it's already nearest centimeter, so that means 100th place. That's fine. Okay, so we'll kind of use approximation even to do the calculation. So let us take the let me sketch one. So we have a open top box here. So we'll assume this to be, okay. So let's say that's the box we're talking about. Now, if you have a box which is sealed from the top, it is a cube which will have the maximum volume and the minimum surface area, right? So the material is given to us as 4 meters square, so that means material is fixed. So for a fixed material, if you have open topped, in that case you will find that the shape is the one in which the base is twice the height. So what I will do here is I'll make another box which has lesser height, right? So I'll make a box here which has lesser box, but the base area is kind of a square. So it's square base prism. So we have a square base here, but the height is smaller. We'll derive the formula in another video, but approximately the dimensions of this box will be, the square is 2x and the height is x. That is to say, height is half of the square base, right? So that's the kind of a box which is going to give you maximum volume, correct? So that is the box which we are going to consider. Okay, so we are given area, that is the surface area, as 4 meters square. So we have surface area of open top as 4 meters square. Now, as you can see from this figure, that we can write down the base area is 2x times 2x. So that is the base area, 2x times 2x. And then we have 4 sides which have exactly same area. So we could write this as plus 4 times x times 2x, right? X times 2x. So that becomes the total area, surface area of our square-based prism, right? So we can kind of calculate x from this particular equation. So what we have here is 4 is equals to 2x times 2x is 4x squared plus 4x times 2x, which is 8x, right? So 8x squared. So what we get here is 4 plus 8 is 12. So 12x squared is equal to 4, or x squared is equals to 4 divided by 12, and which is 1/3, is that okay? So it is 1/3. Okay, 1/3. So x will be square root of this, will be 1 over square root 3. So that is the value of x. We need to find the dimensions. Let's calculate this value. Since we have to find to nearest centimeter, we'll go for 2 decimal places, right? So we have 1 divided by square root of 3, which is in decimals equal to 0.577. So 7. So which we can write to 2 decimal places as, or in centimeters, we could write this as 58 centimeters, or 0.58 meters, right? So that is the value of x. Okay. Now the question is, find the dimensions to nearest centimeter. So the dimensions will be, x is the height, so area of the base is 2x times 2x. So we know that length and width, so now we can get height equals to 0.58 meters and length, which is equals to width, is equals to 2 times 0.58, right? So let's multiply and get the answer, right? So it is 2 times 0.58, which is in decimals 1.16 meters, right? So that is the dimension of this particular box. You can also find the volume by multiplying the area of the base times height, correct? So that is an extension to this question. So we could extend, find the maximum volume. So what is the maximum volume? So maximum volume in this particular case will be base area, which is 4x squared times x, or 4x cubed. So it will be 2x times 2x times x, and that becomes 4x cubed, right? So we can calculate this value, 4 times 1.16 cubed. Okay. I'm sorry, the 0.58. So let me redo it. So 4 times x is 0.58. 0.58 cubed, right? So it is 4 times 0.58 cubed, and that is equal to 0.78 meter cube, right? So that becomes the volume of this square based prism. I hope that helps. Thank you and all the best.